Assalamualaikum. My name Ahmad Rafiq bin Asman. Nama matrik DD210071. I'm gonna present about introduction of this experiment. So beam are crucially structural element resistant bending force, often long prismatic bars subject to load applied perpendicular to their x. Understanding the foundational theory behind beam design is paramount due to their significance in structural system. Beams fall into two categories: statically determinate with calculable support reaction through static method, and statically indeterminate featuring excess support. This experiment uses the principle of moment to illustrate the calculation of beam reaction at each support, highlighting essential aspect of beam behavior.
Okay. So for the result, we can see this table. From the table, it shows two results, which is the experimental value and the calculated value. So for the experimental value, we can get by getting the reading from the spring balance. We can see here, and then for the calculated value, we use the formula given in the lab sheet. So, and then for the distributed load, which is weight of EX at A, uh, we, we get 2.6 Newton. Okay, so for the value, we see it is not same, the comparison, because the experimental value reading is from the spring balance, uh, while the calculated value is we calculate it using the formula.
So hello everyone, let's dive into the result of our beam analysis test. Starting with test 1, both experimental and the calculated value for RA, RB and RA plus RB align perfectly at 2.5 Newton, 2.5 Newton and 5.0 Newton respectively. This consistency in test 1 established a solid foundation. However, as we move to until test 2 until to 8, we notice some variation. For example, in test 2, the experimental value is 5.1 Newton, slightly higher than calculated value, which is 5.2 Newton. This variation prompts us to explore potential source of error. Summing up the forces for each test, we see a range of total forces. Test 1 gives us a total force of 10.0 Newton, test 2 at 10.3 Newton, and so on. These values provide an overview of the overall forces acting on the beam. As we look closer, unexpected variation in total force emerge. It's essential to interpret these results with caution. For instance, in test 3, the experimental value of 10.3 diverges from the calculated value 10.2 Newton. This observation prompt us to consider factors affecting these discrepancies. One crucial takeaway is the importance of accurate load placement. Even minor misplacement can influence results significantly. This highlights the precision required in experimental conditions for reliable outcomes. Looking forward, we propose potential adjustment to enhance the experimental setup. This could include refining load applications, procedures, or ensuring more precise measurements. These suggestions aim to minimize discrepancies and improve the overall reliability of our experiment. In conclusion, this result underscore the intricacies of beam analysis. Careful consideration of load placement and continuous improvement in experimental procedure are essential for accurate the meaningless outcomes. That's all from me. Thank you.
From the experiment, the total result obtained after we repeat the reading for time. which is the experiment value is different from the theoretical value, but the result is almost the same as the theoretical value that has been prepared. The objective has also been achieved when doing this experiment carefully. Although when the experiment was carried out, we found that our balance meter had a problem. With the starting difference at zero point 0.1 Newton. As a conclusion, when already conducting this experiment, we can conclude that we have reached the understanding of the moment principle to apply the principle in real engineering design, such as designing roads, bridge, and large building. We can determine the support reaction to the beam using Newton law of motion and the principle of motion. We were also able to investigate that the total distributed load can be considered as equivalent concentrated load acting in the beam at the center of gravity. Also, the problem we encountered during the experiment was that RB was not accurate enough to reach equilibrium. We also had difficult finding the right load weight to balance the bar in the level position. Finally, the suggestion we discussed to reduce the problem we encountered during the experiment is a good maintenance feat of the apparatus, especially on the calibration of the movement of the critical link of the balance. So, the eyes must be perpendicular to the spring balance reading to avoid parallax error. Perform repeatedly data measurement to obtain an average and accurate reading of the data to avoid any parallax error at least 4 times. And the value we take is average value on the fourth reading.